All right, so here we have L'Hopital's rule again, where f is equal to a, which is f of a equals g of a equals 0. F and g are differentiable, got an open interval. Now what we're saying is, look, instead of just evaluating those limits at a, we can actually look at the limit on both of these guys. So let's take the first one here, and the top equation would be 1 plus x to the 1/2 minus 1 minus x over 2. So the derivative of this would be 1/2 1 plus x to the negative 1/2 minus 1/2. Okay? G of x is equal to x squared. So the derivative of that is 2x. All right, so here's our situation. And what we're going to do is we're going to look at this limit again. And this time we're going to put our derivatives in. So this is f prime of x here. And in the top, I'm going to have 1/2 times 1 plus x to the negative 1/2 minus 1/2. And that's going to be over g. And g is 2x. So when I put 0 in for all of these, you'll notice that, remember, this is 1 plus x to the negative 1/2, okay? So that's in the denominator. So if I put 0 in for x and 0 in for x, I wind up with 0 over 0 again. And if you don't believe me, check it out. 1 plus 0 is 0. The square root of that is 1. So I have 1/2 minus 1/2. Okay? No problem. What we'll do is we're going to take a derivative again. We'll take our derivative of our derivative. And when we do that, I'm going to wind up with an answer that I should be able to work with. Okay? So the derivative then of f prime, so f double prime, is negative 1/4 times 1 minus x to the negative 3/2. And then the derivative of 1/2 is 0. The second derivative of g is 2. So whatever answer we get, we're just going to simply divide that by 2. All right? No problem. We'll do the limit process again. I'm going to have, and I'm going to write it a little bit differently this time, 1 over 4 times 1 minus x to the 3/2 power. Okay? All divided by 2. So now when I substitute in the 0, what happens? I get 1 over 4 times 1 minus 0 to the 3/2 power. Well, that's just 1 to the 3/2 power. So that's 1/4 times 1 divided by 2, which is 1/8. So we had to take the derivative 2 times in this case, and that's not necessarily bad. It allowed us to find a way to get the limit by using derivatives. And so this is a little bit of a stronger version of L'Hopital's rule.